Hey everyone, welcome to This Explainer. I am so thrilled you're here. We spend basically our entire lives online, but if someone actually stopped you on the street and asked, how does the internet work? Could you tell them? Most of us couldn't. Well, today we are going to completely demystify that invisible, lightning-fast infrastructure that powers our daily digital lives. Here is our roadmap for the trip today. 1. Hitting enter. 2. DNS, the Internet Phone Book. 3. Packets. 4. Rules of the road. 5. Routing the global network. And finally, 6. The final delivery. Let's jump right in.
All right, section 1, hitting enter.
So, have you ever actually wondered what invisible magic is happening in the literal milliseconds after you press enter to fetch your favorite website? Whether you're checking the news, streaming a movie, or jumping on a video call, a wildly complex chain of events kicks off the exact microsecond your finger leaves that keyboard. Before we track our requests, though, we really need to clear something up. We have to distinguish the web from the internet. People use these terms interchangeably all the time, but they are entirely different things. Think of the internet as the massive physical infrastructure, the miles of cables, routers, and networks connecting over 4.5 billion users globally. It's the roads. The web, on the other hand, is just a service built on top of that physical infrastructure, like email or online gaming. You use a browser to navigate the web, but the internet is the physical highway actually getting you there. Which brings us to section 2, DNS, the Internet Phone Book. Okay, to find exactly what you are looking for on this massive global highway, we need a directory. Let's look at John here. John just typed www.example.com into his browser at work. As humans, we are great at remembering names, right? Things like google.com or example.com, but computers, not so much. They strictly speak in numbers. So John's computer has to go ask a DNS server to translate that human-readable name into a machine-readable number. And that number is what we call an IP address, or Internet Protocol Address. Basically, it's a totally unique identifier for every single device online. It serves as the exact geographic coordinates for where a website's data lives. Now, today we mostly use IPv4, which supports about 4.3 billion addresses. Sounds like a lot, right? Well, we actually ran out, so we're actively transitioning to IPv6 to offer a massively larger address space for the endless flood of smart devices out there today. But how does that lookup actually happen? It's not just one giant server sitting in a basement holding all the world's addresses. It's a hierarchy. If John's local server doesn't know the IP address, it queries up the chain. It asks the root server, which points it to the .com server, which then points to the specific domain server for example.com. And this entire global game of telephone, it happens in just milliseconds until it pinpoints the exact address. Moving on to section 3, packets, pieces of a puzzle. Now that the browser knows exactly where the server is located, how does the actual website data get back to John? Well, data doesn't just move across the internet as one giant, clunky file. If it did, the network would constantly jam up. Instead, it is brilliantly chopped up into thousands of tiny chunks called packets. Usually, these are just 1,000 to 1,500 bytes in size. Extremely small. And each packet carries two vital things: a header containing its destination and a payload, which is the actual piece of data, like a tiny sliver of an image. I absolutely love this concept. Think of these packets as puzzle pieces. Because they're so small and independent, they don't even have to take the same path. One piece might route through New York, another through London, just dodging digital traffic jams in real time. But once they all arrive at your device, it flawlessly snaps the puzzle pieces back together to display the website. Next up, section 4, rules of the road. So, with millions of computers tossing puzzle pieces around the globe, how is this not just total chaos? To make sure these pieces don't get lost, the internet relies on strict rules of communication. We call these rules protocols. Both the sending server and your receiving device have to follow these standardized protocols to a T. If they didn't, they'd basically be speaking two completely different languages and nothing would load. The absolute backbone of how this works is TCP/IP. The IP, or Internet Protocol, routes the packets to the right address. TCP, Transmission Control Protocol, is the manager, ensuring those packets actually arrive and get put in the right order. Meanwhile, sitting on top of that is HTTP or HTTPS. That's the protocol fetching and formatting the actual text and images for your browser. And that S in HTTPS, super important. It means it's secure, encrypting your data like credit card numbers so nobody can intercept it.
All right, section 5, routing the global network.
So our packets are uniquely packaged and our protocols are locked in. Let's look at the physical hardware moving this data. People mix up modems and routers all the time, but this is a super easy way to separate them. Your home network uses a modem as the door. It physically connects your house to the wider internet provided by your ISP. But your router, that's the room organizer. Once the internet comes through the door, the router directs those packets to the correct device, making sure the smart TV gets the 4K stream and your phone gets your emails.
Let's zoom out and see how this builds into the wider world. From your router, data leaps across local network switches and massive ISP networks. It navigates global routers that function exactly like highly efficient post offices, constantly reading packet headers and tossing them to the next closest node. And the craziest part? For most web requests, this entire globe-spanning round trip takes just 20 to 200 milliseconds, literally the blink of an eye. Which brings us to Section 6, the final delivery. Let's summarize this whole incredible journey. Step 1, you type the URL. 2, your computer asks the DNS to find the correct IP address. 3, we establish a secure TCP connection, often called a handshake. 4, we send an HTTP request asking for the web page. 5, the server responds, breaking the files into those tiny packets and blasting them across the global network. And finally, step 6, your browser catches the puzzle pieces and renders the page right on your screen. Boom. Before we wrap up, I just had to include this timeline because it's absolutely fascinating. It really puts into perspective how far we've come. Look at 1969. The very first internet message was sent over ARPANET. They tried to type login, but the system completely crashed after just typing LO. Fast forward past 1989 with the invention of the web to today, where we have this lightning-fast, hyper-complex infrastructure that we honestly use without a second thought. So I want to leave you with this thought. The next time you casually click a link or load up a stream, just pause for a second. Ask yourself, is this invisible globe-spanning infrastructure incredibly fragile or miraculously resilient? I mean, given the billions of microsecond processes, protocols, routers, and packets firing across the world every single time you hit enter, it's kind of amazing it works at all. Thanks so much for joining me on this explainer. Keep learning, keep asking questions, and I'll catch you next time.